In this video, I will talk about how to solve differential of equation. We usually need to do that in equations of motions. Okay. You probably most likely that you have done something similar in the past, either in a math course or physics course. But here I just want to give you a review if you feel like you need a refresh. Okay. So let's look at the first problem. Consider a free-falling, like vertically object with a linear drag, and I want to find its motion. So usually when we want to find a motion, so this is talking about like a ball like coming down, and then the free body diagram would be it has a drag force, and it has Fg. Okay. And then usually what we're interested in is the motion, right? We want to know either the motion respect to the time, position, like at what time you can find it at what position, or we want to find out the relationship between, when it falls like 100 meters down, what is the velocity at that point? So we're interested in like all this kind of motion. Okay. So let me show you how to do them, like each of them. Okay, so first we have to draw the free body diagram, and we do F equals to ma. Here it's just 1D, so I'm gonna just do this as my, the only axis. So force here is mg, assuming down is positive. So it will be mg minus bv equals to ma. Okay, so this is already 80% of the work. Now we just have to solve that like all the physics just stop here. Okay, so now let's solve it mathematically. So first, let's try to solve for Vt. Okay, so we want to know the relationship between the time and the velocity. So here, this is constant. There's a velocity here. Okay, this is constant. This one, it's a, but it's actually the first derivative of the velocity respect to time. So let me rewrite my a to be dv dt. And when I rewrite my a to be dv dt, then this equation will be mg minus bv equals to m dv dt. Okay, cool. So this is a differential equation, and now I want to solve it. So let's see. I have a dv on this side. So eventually what I want to do is I want to move dt to the other side, so I can integrate both parts to get rid of this derivative. But if I put the dt to the left part, you will see that this term is actually dependent on the velocity. So to make our plan work, we need to, let me make one more step so you know what I'm saying. Okay, eventually we want to do something like that and integrate it out, but the thing is like this guy has a velocity dependence, so meaning it also depends on t. I cannot just integrate it out and pretend this is a constant, because it's not a constant. Okay, so for example, when you do this integration, what are you gonna deal with that, right? So the trick here is you want to move all v to one side and all t to the other. Okay. So meaning I'm going to move this to the right by dividing this on both sides. Right? Okay, so now I have all the v dependence here, all the t dependence here, which there's no dependence really. So I will just integrate it out. And I will get t equals to, then I need to do the integration of this one. Okay, and since I already integrated this out, don't forget that there will be a constant here. I can fix this constant later with my boundary condition. Okay, so now I am here. Okay, so I'm going to assume that this, I'm going to say this is my u, I'm going to do a change of variables here. Or you can just look up your integral sheet to find the answer. I'm just gonna do it in an old class way. So I'm gonna assume u is negative bv here. Okay, so du is negative b dv because this is a constant. So dv is negative 1 over b du. Okay, so with the change of variable, I'm going to swap all the v with the u. So dv is this. And this is mg plus u. Right? Okay. So this one you can look at on the your integral table, but this will essentially give you a log. And of course that I want to swap, eventually write my answer in terms of the velocity, right? So I will swap my u to be negative bv and put it back. Okay. Now let me continue my work to the next page. Okay. So here I essentially have the relationship between the time and the speed, right? These are all constant. So now I just need to rearrange it so that I get something like a v equals to blah 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 t. Then that's my vt relationship. Okay, so let's see. I definitely encourage you to pause the video and try to do this yourself. But you can also just follow, my step and see whether we are, agree with our steps. So what I'm gonna do is I'm going to isolate the v because I want it on only one side. So let's multiply negative b over m on both sides. If I multiply negative b over m, this will be canceled out to be this. And then a constant multiplied by another constant is just a constant which is not determined anyway, so I will just keep calling it constant. Right? This is something that will be determined later by my initial condition. If you don't like it, you can call this constant 1 and call this constant 2, and yeah. Okay, and then again I want to isolate it, so let me remove this guy and move it here. Okay, then I will take exponential on both sides. Okay, and then now what I'm gonna do is I'm going to bring negative bv to the left and this whole thing to the right. Okay, so here it looks kind of ugly here, so I want to simplify this term a little bit at this stage. If you don't, that's completely fine. Okay, I just don't like this format. So here I'm going to use the fact that exponential alpha plus beta equals to exponential alpha exponential beta. So I will take this one out, and this will be exponential negative constant, which is really just a constant, okay? in the end of the day, and I will determine this constant later. So combine these two, constant over b is also still a constant, so I'm gonna just call it constant. All right. So assuming that this ball is falling with no initial velocity, okay. So here we pretty much have our answer, but we just need to determine what is this constant. So let me plug in the initial condition. Okay, if this is 0, this becomes 1. So that tells me my constant is nothing but mg over b. Okay, so plug it back in here. We get v equals to mg over b minus mg over b exponential minus b over mt. Okay. So you can see this makes a lot of sense, right? Like when time is 0, this is 1. There's no velocity. When time becomes infinite, then this doesn't matter. Then my speed will become this terminal speed, will become a fixed number because it will just fall and then eventually reach a terminal velocity. Okay, so that's my VT relationship. So now, next, if we want to find the XT relationship, what can we do? We can just rewrite v in terms of dx dt equals to this whole thing. Okay, I kind of like factor out the mg over b, so to simplify my math a little bit. Okay, so again, I want to find my x, right? So I need to do exactly the same thing, which is put all the x dependent to the left and put all the t dependent, along with the t on the right. Okay, so let me times dt on both sides. Let me move the dt over. Okay, so you see, this are constant. This has a t dependent, so that should go with this t. I don't have x dependent really here, so there's nothing here. So now this is all good. Now I can integrate it out. Then I will get x to be blah, 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 blah. Okay. I will leave that to, let me see what I have, this format. So I'll have mg. If you work out the integral here, then you will get this. Okay. All right. Then you will get something like this. All right. So now I want to talk about, now with this too, the last thing that we're interested in is we want to figure out, what's the relationship between v and x at a certain position? What's the velocity at that position? Okay. So how to do this? A naive, a very straightforward thought is I have vt, right? And I have xt here. So why don't we just substitute the t, and we can rewrite this t in terms of v, plug this in, then we would come to an equation with only x and v. So yes, you can totally do that. Okay, but here you can imagine it's gonna be quite messy. So here I'm going to talk about another way to do it. So the way to do it, so another simple way to do it is I want to go back to my very fundamental f equals to ma. Okay, so let me go ahead and solve this again. But this time, I'm going to rewrite my a. So remember we talked about this trick in the class where a is dv over dt. but I can times dx on both sides and then swap these two in the denominator. Well, this one become v, and this one become dv over dx. Okay, so I'm going to replace my a with v dv over dx, and then now you can see I have an equation with only v and x. So whatever I work out here, that will be what the answer we are looking for. Okay, so let me do it step by step, so that we have more chance to practice. So mv. So let me first, move this dx to the left hand side. All right. So we cannot do the integration yet because this side still has a v dependence, which we don't want. We only want the x dependence on the left, and this side is good. So let's divide this whole thing. And then you will integrate it out. Okay, now we are good, right? Then we can integrate it out. All right. Okay, so I'll leave this integration to you. You can do some substitution, or you can look it up on the integral table, or you can use mathematics or whatever. But eventually, you will get an x in terms of v, and when you isolate v, then you can find the function of v in terms of x. Okay, so let's come back, and so this is a general process to solve a differential an equation of motion. Let me just quickly review it and tell you a few points that you need to be careful. So first, you want to make sure that you draw the free body diagram right, and with the nice F equals to ma. And make sure you choose a coordinate. Okay. And then once you choose a coordinate, you will split into x, y, z, or theta, phi, or a different directions. And in each directions, you will eventually come to this. And then from here, you can depend on what are you looking for. If you're looking for vt, then you can swap your a to be dv dt, and then just carry it out like this. Okay. If you jump too fast and rewrite your equation like this, then you might find yourself, getting stuck, because you may find this is become too complicated because you have a t dependence, you have x dependence, you have v dependence, and they just become too complicated to solve. Okay, so you need to observe your equation a little bit and choose a smart way to do it. If you're doing VT, you can replace your rewrite your A in terms of dv dt and then solve it. Okay, you will have the same practice on the homework number 5 and 6. Okay, and then after that, you can, if you want to find xt here, then you can just, because once you have the v, you can rewrite v in terms of dx dt, and then integrate out both parts to get the x. This part is something we will practice next time, is the vx relationship, and the trick is to just go back to the original equation of motion and swap your a to be v times dv dx instead of the dv dt. Okay,